Hello everyone, welcome to another IGCSE Mathematics tutorial. Today we'll be discussing the first topic in the second chapter, Algebraic Manipulation. Firstly, let's talk about simplifying expressions. Knowing how to write out an equation properly is essential. Let's establish some practices before going forward. We'll start off by simplifying a multiplied by b multiplied by c. We get ABC. We don't write out the multiplication signs and we combine them all together into one single term, ABC. Now we'll simplify 3 multiplied by a multiplied by b. Similarly, we get 3ab. Again, combine them all into a single term. Following up, we get 3 multiplied by a multiplied by 4 multiplied by b. This time, since we have two constants, we can multiply them. We get 3 multiplied by 4 gives us 12ab. Now we'll work with all of these practices put together. Let's simplify this equation. 4 multiplied by 3p multiplied by q multiplied by 2p multiplied by q squared. 4 multiplied by 3 multiplied by 2, all the constants together, we get 24. P multiplied by p, from the 3p and the 2p terms, we get p squared. Q multiplied by q squared gives us q cubed. Combine them all together, we get 24p squared q cubed. Beyond the rules of multiplication and the division, we also need to simplify equations by collecting like terms. Like terms would be, if you have an equation, let's take this example, the 2a and the 2a squared and the 5a squared would be like terms because they both have a squared. 3ab and 9ab would be like terms as well. If you had, for example, 3ab and a term with just a, these are not like terms. Let's simplify this equation. 2a squared plus 3ab minus 1 plus 5a squared minus 9ab plus 4. We add the coefficients of the like terms to get the simplified equation like this. First, the coefficients of a squared. 2a squared plus 5a squared gives us 7a squared. We're collecting them. 3ab minus 9ab gives us minus 6ab. Minus 1 plus 4 gives us 3. Combine it all together. We get 7a squared minus 6ab plus 3. Let's talk about expanding products, such as this one here, 3a brackets 2a minus 4b. To expand this, you multiply each term inside the bracket by each term outside the bracket like so. 3a multiplied by 2a minus 4b would give us 3a multiplied by 2a plus 3a multiplied by minus 4b to give us 6a squared minus 12ab. Similarly, we can expand an example like this with more than two terms inside the bracket. Once again, just multiply every term inside by the term outside. 5a multiplied by 3a plus 5a multiplied by minus 2b plus 5a multiplied by 1 would give us 15a squared minus 10ab plus 5a. To expand expressions like 3ab in brackets, and then in another set of brackets, a minus 4b, multiply each term in the second bracket by each term in the first bracket, like so. 3a multiplied by a, the first term in the first term, 3a multiplied by minus 4b, the first term in the second term. Then we have b multiplied by a, the second term in the first term, and then b multiplied by minus 4b. Take care to keep the signs as they are. We get 3a squared minus 12ab plus ab minus 4b squared, and this can be simplified down even further because ab and 12ab and ab are like terms. So we'd add minus 12ab to ab to get minus 11ab. Let's talk about algebraic factorization. Factorization is the exact opposite of expansion. Simply find the highest factor that all terms have in common and take that factor outside a set of brackets. Write down the terms needed to make the original terms. For example, to factorize 6x squared plus 9x, we would take 3x outside the bracket and we'd write down 2x plus 3 inside the bracket. Since 3x multiplied by 2x gives us 6x squared, 3x multiplied by 3 would give us 9x. Let's write with this example. 4ab plus 10b squared. The highest common factor is 2b, and our inside terms would be 2a plus 5b, giving us 2b plus multiplied by 2a plus 5b. Let's write this time with three terms, 15ab plus 5a plus 20a squared b. Our highest common factor here is 5a, and our inside terms would be 3b plus 1 plus 4ab, giving us 5a brackets 3b plus 1 plus 4ab. Lastly, we'll talk about completing the square. Some questions will ask you to express an equation in the form x plus b squared plus q. These questions can be solved by a method called completing the square. It's just another way of saying that you're rearranging the equation in that form. Let's take an example. X squared minus 10x plus 15. This equation is currently in the standard quadratic form, ax squared plus bx plus c, where a is the coefficient of x squared, in this case 1, bx is the coefficient of x, minus 10, and c the constant. Plug these values into this formula, x plus b over 2 all squared, minus b over 2 squared plus c. Our example would give us x plus b over 2, in this case it's minus 10, so we have minus 5, we have minus 10 over 2, which is just minus 5, all squared, minus 25, which is again 10 over 2 squared would give us 25, and then we have a negative sign, so it would give us minus 25 plus c, which is 15, gives us x minus 5 all squared minus 10, which is our final answer. Thank you for watching. Make sure to like, subscribe, comment any questions you have, and feedback, as well as look back at our channel for other videos.